This video is over topic 22, practice problems, looking at the empirical rule for normal distribution. So this is based on when you know data values are within a certain number of standard deviations from the mean. So within 1 standard deviation or 2 standard deviations or 3 standard deviations from the mean, that those represent particular percentages of the data values. So that's part of what defines the normal distribution, is that these percentages occur. So the main thing is to learn that the one within 1 standard deviation of the mean means that from the mean in the center there, the highest point in the center, that you subtract the standard deviation 1 time and get that lower end number and add the standard deviation to the mean to get the higher end. So those would be these values here would be mean minus standard deviation, and then the mean plus standard deviation would be the data values that would enclose that grouping of the data. And then if we go out and we go ahead and add the standard deviation to the mean twice and subtract the standard deviation from the mean twice, then we get that covers now 95% of the data that are between those two values. And then if we go one more standard deviation in either direction, now we're including 99.7% of the data. So here's a diagram summarizing all of that. You need to know those numbers and what they correspond to, that the 68% is 1 standard deviation on each side, 95% 2 standard deviations on each side, and 99.7% 3 standard deviations on each side of that mean value in the middle. So looking at the practice problems then, so number 1, the mean number of M&Ms in a typical 1-pound bag is 517, standard deviation of 12. Then we can label a normal distribution curve. So always the mean value is going to go here in the middle. This middle line is highest point, middle value. That's the mean for a normal distribution. So that goes there. And then each of these vertical lines, what we're doing here is we're counting by the standard deviation. So we're treating that standard deviation is the distance between these vertical lines. So we're going to take that mean value and start adding by 12. So 517 plus 12 is 529. Plus 12 again is 541. And plus 12 again is 553. And then going the other direction, if we subtract minus 12, 517 minus 12 is 505, and 505 minus 12 is 493, and 493 minus 12 is 481. So then if we're asked what percent of bags would contain between 505 and 529, I find those numbers here on my labels, and I see those correspond to this area closest to the mean, just within 1 standard deviation above and below the mean. That's the 68% area. And then if we want to go 99.7%, we need to go all the way out to the third line on each side. And so that's going to be the 481 and the 553. All right, then the way you'll be asked to do any curve labeling in ALEKS is with a question like this. So first thing to note on this, or one thing to note on this, is these given labels here, you're not going to do any calculations whatsoever with those numbers. Those numbers are only to help you line up where things are going to go. So let's just go and make the normal curve diagram with the 3 on each side. We're going to put the mean in the middle, 68.6. That's V. V, it says, is under the highest point of the curve. That means it is the mean. exactly as given, no changes. V is the 68.6. Then we would label and we would start adding 1.5. So this distance between the lines is 1.5. So 68.6 plus 1.5 is 70.1. And then if we add 1.5 again to that, we get 71.6. And then add 1.5 again, and it's going to be 73.1. So those would be the labels. And then if we go the other direction, subtracting 1.5, we'd have 67.1. And then again, subtract 1.5 from that would be 65.6. And then subtract 1.5 again, that would be 64.1. So adding and subtracting the 1.5. But here on this label, then we only are going to have two of them, but they're going to be a matching pair. So it's either going to be the 67.1 and the 70.1, or the 65.6 and the 71.6, or the 64.1 and the 73.1. So then I use those given labels to figure out which pair fits those. So the one on the left needs to be between 64 and 66. So that eliminates, it can't be the 67.1 because that would be over here somewhere. And it's probably the 65.6 because 64.1 would be way over closer to the 64. But we can check the other side. So it needs to be between 70 and 72. So we have the 70.1 somewhere over there, the 71.6 also fitting between there, but the 73.1 would be over beyond the 72. So it can't be that. So the only pair that fits both of those is the 65.6 and the 71.6 that are the same distance each side, as specified, the same distance from V. And this is 68.6 plus 2 times 1.5. And this is 68.6 minus 2 times 1.5. 2 standard deviations above and below. And so the other thing you need to know is that if we go 2 standard deviations each side of the mean, that is going to be the 95%. Now, you may also go the other way, so you might recognize the shape because we're going to have generally, if you think of like the 68%, it's going to be landing about halfway vertically down, so that would be more like over here. So this seems a little far out to be the 68%, and then the 99.7% is going to be much lower down, like really close to the bottom. So you might recognize the shaded areas like that looks like the 95%. And then if you know it's the 95%, then you know it's going to be 2 on each side, 2 standard deviations added to the mean and 2 standard deviations subtracted from the mean. So either way, if you recognize the shaded area and what percentage that should go with, or if you use the sort of the given those labels to help line up where how many times you need to add and subtract the mean to get that U and W value. So that's 5%. All right, and then number 3, a light bulb manufacturer finds that the lifetime of one model of light bulbs is normally distributed with a mean of 1,600 hours, standard deviation of 300 hours. And so we're looking at not even labeling a normal distribution curve, just using the information about the 68, 95, 99.7. So what percentage of bulbs would last between 1,300 hours and 1,900 hours? We just need to figure out how far away those are from the mean. How many standard deviations is that? So how do you get from 1,600 to 1,300? You subtract 300. And how many standard deviations is that? That's 1 standard deviation. And then similarly, 1900, to get from 1600 to 1900, you would add 300. And that is, again, 1 standard deviation. So these are the values that would fall 1 standard deviation below and above the mean. And so that would cover the 68% of the values would fall within that range. So because it's 1 standard deviation on each side, that's the 68%. And then 95%, you need to know that that's going to be 2 standard deviations in each direction. And so you might go 1600 minus 300 once is 1300, minus 300 again is 1000. Or you might go ahead and go 1600 minus 2 times 300, or 1600 minus 600 to get to the 1000. You might go ahead and go here, 2 standard deviations is 2 times 300, which is 600. So you're going to take 1600 minus 600 on one side, 1600 plus 1600 on the other. Or you could do it one at a time. So 1600 plus 300 is 1900, plus another 300 is 2200. Either way, it's 1000 and 2200. Now, be a little careful if you find both those numbers. If you tend towards like wanting to do the addition first and then the subtraction, that's fine, but you still need to put the smaller number in the first blank and the larger number in the second blank for Alex to recognize that. So that is topic 22.